With great honor, I welcome the professor to enlighten us on the Sophie Germain identity. Thank you.
Thank you, Ankan, for introducing me. You have told more nice things that I could have told about me. Thanks. Okay, so am I audible to everyone? All at least one person can say yes. By induction, I will assume everybody is there, right? Okay.
Yes, sir.
I want my base case. Yes, Ankan is my base case. Then Ankan says yes. I'm audible perfectly.
Yes.
Yes.
Echoing, the voice is echoing.
Echoing. Okay, so let me just do some fiddling. I think now it should be okay. Maybe I'll just check.
Yes, sir. Yes, sir. It's okay.
Okay, yeah, it should be because on the same thing I took IMOTC lectures also. So I think this is tested. Okay, so now let me just share my screen. Not used team much, but still. Okay, so is my video on? Is it switched on or no?
No, sir. No, sir.
So I think it is here. It should be. Okay, the option will come later, right? So first of all, okay, this is here for me. I get it. Okay, again, welcome everyone. Let me share the screen now and present things. Okay. So first of all, let me tell you something about this identity. Although I am told that the students are of also class 8. So I mean it consists of this audience consists of class 8 and 9 and 10 and 11 until 12, right? So so that way, I think I chose some topics such that even students of class 8 can appreciate, right? At the same time, you know that maths is really abstract. And so the case really rises. I mean that you can start with something and then suddenly it goes to a next level. So I will try to build up the intuition as is the job of a math lover or somebody who's training you. And also I would be giving you actual contest problems so that you can appreciate. I understand some of you might have done some problems earlier. That does not take away from you the pleasure and fun. So please enjoy, especially my commentary, because I try to give lots of motivation in my classes. And so that way, I think it will be a useful session. Okay, so the first, can you see, I have shared the screen. Can you see it now? The question that is on the screen? Yes,
Yes.
one
Yes,
person.
sir.
Okay. So this is actually a very easy question, right? Because first of all, let me write the identity because I will assume I will start from the scratch and then develop. So first of all, a to the 4 plus 4b to the 4. You can also read about Sophie Germain, her history, right? At a time when she was there, like people, especially women could not do maths, right? So she has to change her name and other thing. You can, it's a better story. I think so. You can just check the Google. It will be really good for you. Okay, so this is here that if you have got this one, a to the 4 plus 4b to the 4, good old factorization will come up and you will get a squared plus 2ab plus 2b squared and times a squared minus 2ab plus 2b squared. This kind of thing will come up, right? Now, this kind of thing comes up because you are just writing as a sum of two squares. First of all, you're writing a squared whole squared and plus 2b squared whole squared. And then you are saying that you want to make x squared plus y squared plus 2 times xy. So a squared times 2b squared, and then subtract this thing, that is 4a squared b squared. And it's nicely factored, right? 2ab squared come up. In fact, a4 plus b4 also somebody can factor, but not nice, right? Means coefficients are not integers, right? So we got this kind of thing. Now we can write a couple of remarks about it, which will be useful. Even if you have done, please bear with me. And so a plus b whole squared, because some of you are too young and it is basically aimed at all kind of people. A plus b squared plus b squared and times a minus b squared plus b squared. Now it really helps to note that if you take a and b to be positive integers, which is what we'll work with today, not even 0, in that case, this factor, the second factor that I'm saying, it is always less than the first one, right? I mean that a minus b squared plus b squared is always less than a plus b whole squared plus b squared, right? First of all, it cannot be greater, and it is equal only when either a or b is 0, which is not the case here. And so we will say that the second factor is always less than the first factor. So I suggest all of you about proof writing also, that when you're writing the proof, then try to write these things. So that will bring down the clutter and you are more composed, and then you can check that yes, this kind of thing is coming up. Now let's see that this one. So first of all, is there an integer n such that this is prime? This is the question. I'm sure all of you can do it. I'm sure all of you can do it. Okay, there was a question in n to the 4 plus 4 or some question was in earlier. No, you will find it was still that for what n greater than equal to 1 it is prime. So it happens that for only n equal to 1. It is just some kind of extension to that. So how many of you can solve that? Do you have the can we do a poll or something? Or if not, raise the hand, something like that. Yes. Is there some facility here? No, something.
We can't do a poll, but
okay, no issue.
they can raise
Okay.
their hand.
Okay, I'm not sure how this interface works much, but then is my video on or it's not on? Still, it is switched on?
Yes, sir, it's on.
Because it is not, I'm not able to see this where it is. Okay, but anyway, that is. So I mean, I was more adjusted to other thing, but this MS Team also have used. Okay, coming back to this one then. Okay, guys. So this second factor is less than the first factor. How it translates in working is like this, that if you have to prove it is prime or not, first of all, little things that n less than 0 anyway, not an integer. So the question does not make sense. So that is gone. N equal to 0 if you put, then expression I will tell e. So this whole thing e, that becomes 4, and that becomes 4 plus 5, that is 9. And so of course it's also not a prime. And when you get n greater than equal to 1 or positive, I will write greater than equal to 1 better. No, I prefer this instead of this, so I will write this. So if this is the case, then you are saying that, okay, this 4 tells you now that it may be a job for this one, Sophie Germain identity. This was the identity, the box one that I have did, right? This one. So now you are writing. So we will write like this. We will say that, okay, this E equals. So I'll write this one first. I follow the order. So 5 to the 4 to the n. This I want A4, so I'll do it little thing. And this is 4 into 4 to the power 5n minus 1. And this again I will write 5 to the 4 and whole to the 4 to the n minus 1. I hope all of you remember your laws of exponent, which gave you much trouble while you might have been a kid. So now this is 5 to the 4, it serves as A, and 4 to the 5 to the 4 to the n minus 1, that serves as A, and 4 to the power 5 to the n minus 1, that serves at B. And because n greater than equal to 1, so I can say that, okay, A and B both are like greater than 1. Although it is much more, but this serves our purpose. So this I will write again as 5 to the 4 to the n minus 1 and to the 4 to make it look like this one, 4 to the power 5n minus, oh, this is 5n minus 4, by the way, whole to the 4, right? So write this 4, this one. So we have identified your A and B, this one. And then you are saying that come here now. We want to prove it is prime or not. Come here. That's what I did. See, the smaller factor, A minus B squared plus B squared. Please listen carefully. The smaller factor, if B is greater than 1, greater than equal to 1 or greater than 1, then this itself exceeds 1, right? No matter whatever A and B are. No, they may be equal also. We do not care. But the moment this B exceeds 1, it means that this whole factor greater than 1, and because the smaller is greater than 1, the greater factor have to be still greater than 1, right? And so we have proved that this is a product of two numbers. This is an important point. This is the product of two numbers, each of which, not one, each of which is greater than 1. No, if you can prove only for one, then you are not done, because then it is trivial factorization. Maybe you are doing something like 13 equals 1 times 13. So this only this is greater than 1. So it means you have to prove in these things that it breaks into two factors. It decomposes into two factors, each of which is larger than 1, each of which. So it amounts to the same
We
thing.
can also show if the minimum of the two is greater or equal to 1.
Yeah, so that's same thing, smaller, correct. That's what I did. That there are two factors, right point, two factors. So I will just show that the smaller of the two, that this one is smaller of the two, the smaller of the two exceeds 1, and so larger has to, we don't check only. So this is the kind of reasoning that is required. Okay, this is a very pretty simple example, just but they really serve the purpose. I love these kind of examples because they're instructive. No, for example, any AMGM class will start for the basic A plus B, B plus C, C plus A greater than equal to 8 ABC, right? This is the mother of all examples, right? And then you keep changing the rules of the this one games engagement, and then you keep getting different problems, right? But deep down, if you believe, okay, it is this problem, it is again that problem. Of course, packaged differently, disguised much more like that. So this is the problem that I want to tell. This is what this one, A plus B whole squared plus B squared. So this, of course, many of you be knowing. This thing maybe I have added that you check for the smaller one. That is where your marks will be there, your credit will be there, and it will tell you understand the thing that yes, smaller is larger than 1. Now, to whet your appetite, let me show you one problem which was asked in, and then some personal history. One question, see, you can see this one numbered. I have not numbered, so see this one. You see RMO India. It is 2009 actually, not 10. So that you can check later. 2009. You can view it later also. I hope recording will be available. So this is 2009, right? So this is all right. This is RMO. This is Regional Math Olympiad, our own country's exam, RMO. And do you see just before that? This is again RMO only, but Romania, right? Curiously, this is also, I will say Romo. No, RMO and let's say Romo. Okay, to distinguish. Although ROM is the code for it, but Romo. So see how these two problems really, there is uncanny resemblance, right? You can't miss them. See, now it's your job to find out who inspired whom. Okay, but anyway, I would rest my case by saying that that is kind of thing that, see, contest writers are always looking for those problems you can anywhere you can take, anywhere you can learn. Contest writers, I know them very closely, many contest writers. I myself have written contests. So we are always looking for those things which really everybody knows, even a high school student, but still when they try to work on it, then they will feel the difficulty of it, right? It is often said that problems worthy of attack prove their worth by fighting back, right? Means they will also fight back. You fight and they will also fight back. They will defend their fort. No, I am impregnable. And you will say, no, I know now how to just break. No, like in Indian mythology, it was Chakravyuh, right? So Chakravyuh or something, you have to break that. So Abhimanyu knew how to go inside, but he did not know how to come out of it, right? So you have to understand that you have to come out of it. I mean, here, come out of it means the Chakravyuh, that time is there, right? There is a clock ticking. So you must know how to enter. So you know how to enter. You know that Sophie Germain is the thing to enter. So you entered Chakravyuh, no? And then you have to come out of it. It's not that you have to get martyred there. Okay, so those kind of thing. So this all will come from practice. But I love both problems. Both are good for training. In fact, I knew this problem before also because T2 told me about it. The author was actually Dorin Andrica, this Romanian. Dorin is another like co-author of T2. I have a pleasure to know both of them. Okay, so it was proposed like there. And then, of course, you will also find some Korean competition, same kind of questions. Like, so it happens. Now, good problems are like good jokes. They travel far and wide, right? Like I will learn a joke and I will try to suit it to my audience, right? So you will suit it. That okay, let me give a new and fresh look. So those things keep happening. Okay, guys. So this I will do a little later. This was just to tell you the things to come. Then this is matrix also. So you can see that because some students are in class 12 and 11, so they would appreciate that what is this is matrix. You will say it is algebra, matrix is just an excuse. I mean that those who know Sophie Germain, they will laugh at this problem, that I know what you are talking about. This is what matrix? It is Sophie Germain only. Okay, so that kind of thing you will have. Okay, this is again telescopic series. Looks like telescopic series, then a telescopic product and all these things. So it's a collection different. You will get somehow Pale's equation also. So let me do one simple problem. Let me ask you to do rather this, right? This one, this second one. This is not, the second one is this one for me. So this third one, I think this will be pretty straightforward. So I give you a minute or two. You can unmute yourself, but one by one, and you can tell your thoughts that yes, Alok, I see this. Coefficients tell me a story. Feel free to unmute yourself and in an orderly fashion.
This
Aryan
is
is
x plus
here.
1.
Yeah, x plus 1. What's your name?
1 to the power Shaurya.
Shaurya, good Shaurya. So good. So of course, many of you also might have got maybe that Shaurya, of course, like he is speaking, but I'm sure that many of you are silent people and you must have got. See, anyway, 464, you know, this is the hint. See, in the chapter of Sophie Germain, you will of course look for it. But even if it is not there, then you should also look that, okay, it looks like 14641. So first job is that, of course, it's too hard to resist that Pascal triangle, right? So of course, your mind will be tuned that let me write first x to the 4 plus 4. I'm assuming that this is not the chapter because this Sophie Germain going on. So you have no idea, one person. So how will motivated? Because this is not, imagine this is not here written, right? You are appearing some exam, some contest. No, not Olympiad, but some kind of American Maths Contest, AMC, or some kind of IOQM, where these kind of things, and in that language, no, they will of course package it differently, or roots, number of roots, something like, okay, real roots. Okay, so now this is, see, if this is there, then this tells you a story, and so you say that, okay, this really cries for 4x cubed plus 6x squared plus, let me write little big, although I can't help much. I did handwriting analysis course in IIT Kanpur, and I was very good at like doing that analysis also, handwriting analysis. Okay, so I found that scientific people normally write a small. You will find good things. No, or even signature will tell you a story. Like Gandhi used to sign with small, right? You will find small things. So it was told that he was humble. Of course he was. Okay, so that kind of thing you will find. So okay, so coming back to this one, x to the 4 plus 4x cubed. If it is not visible, let me know. That is x plus 1 whole to the 4. That is, so I'm elated. Oh, it is x plus 1 whole to the 4. Then what remains is 324 x to the 4 and plus x plus 1 to the 4. Now Sophie Germain comes to our mind that 324. What is that? That's 4 times 81. And that's all right then, because this is like, I will write x plus 1 to the 4 and plus 4 times. So my a has come and 4 and a has come, then b also will come, right? So this is 3x whole to the 4, right? No, it's like if winter has come, spring cannot be far behind, right? So x plus 1 to the 4. So we are looking for this, and slowly they are coming. No, good problems are like that only. You take one step, then they will also take a step towards you, right? Sometimes it may be that you may misjudge them. We all do all the time, especially in Olympiad, because the whole idea of Olympiad problems is that no matter howsoever you know in the field, the problem must stump you at least. It should tell you, to force you to know these first things, these first impressions or first 8 things are not working. Okay, but anyway, so this is this. After this, it is plain. You can do it now, right? After that, this is not a problem. You will quickly write this, and you have done our job, because everything is integer, and so they will all turn up integers only. So this is one question is okay. I have tried to give you a systematic exposition of all the things as I do in my all classes. So I try to weave my story around a theme, and then it's like poetry. I will try to present the best problems in best order, right? So those kind of things. Okay, so this is one. Let me go and Any doubt till here? I hope there is none, but still you are welcome. Okay. Okay. So let me go to the next one. No, here first. What about this? This suddenly is like larger. Can you work on it for a while? You have to evaluate this.
Sir, we can raise a poll.
Okay.
You want?
So raise a poll right now. I think when answer comes in, I can raise a poll, right? If some answer comes, then I can say that this is correct,
Yeah.
this is true or false, right?
Yeah.
Oh, thanks for letting me know. But why it is not showing here? No, this like in some interface it shows here that create a poll or something.
I just added a new app to create a poll.
Okay, okay, good. So you can create, you can create the poll. Let them work on it for some time. Meanwhile, I can give them the answer when they get it. If someone is ready, then he can let me know. This will require some work. Okay, can someone let me know that what they are thinking?
Sir, can you think of x square plus 2 whole cube?
X square plus 2 whole cubed. Is it there that it is coming? X square plus 2 whole cubed?
And then subtracting a part.
Might be. Might be. Looks good.
Sir,
Just
I
work on it.
think
Just work on it. What's your name? The one who said X square plus 2 whole cubed?
Sir, Orkodev Manna.
Arko.
Yes, sir.
Okay, Orko. Okay, I'm good at pronouncing Bengali names, don't worry. So Orko, X square plus 2 whole cubed. That looks a really good lead, but see what else is coming. There is some girl also who is trying to say something, right? Somebody is the second. Does
sir,
someone what? Yeah.
so I think we can do one thing like that. 4x to the power 5 is there, and also we have the 16x. So say if we take the 4x common, then x to the power 4 plus 4 will remain. And also if another place, if we see that x to the power 6 is there, and then the 16x square is there. So from that, if we take x square common, then x to the power 4 plus 4 into root 2 to the power 4 would remain. And already we need to find something with root 2 only.
No, but
Means
then I think
means that
you won't get the. You're trying to plug in the values or what? You're trying to plug in?
so no, first a bit of simplification and then if I plug the value.
Okay. That also can work. But I would like something. See, just okay. So one thing is this. Yeah.
So we have like one term like 1 by the form of the evaluation is 1 by p of x plus 1 by p of
Yeah.
minus x.
Yes. Good.
So like we can group the even degree terms and the
Yes.
odd degree
Means
terms.
this means good thing. Means you focus like this. What's your name?
On
Okay. So you focus like this. 1 over p alpha plus 1 over p minus alpha, right? This one.
yes.
Okay. Good. So it means that
Fourth root of 2 is
correct.
a irrelevant thing. Yeah.
So I think that's a good thing. See, all of you can appreciate this fact that but I really am waiting for that the one who said x is equals to whole cubed. This one, no, this one or something. Somebody said, and he might be working on its lead. So if it leads to something useful or not, let me know. Okay, so coming to this problem, I would do like this. It's a little bashing, but maybe some of you can find the way to get out of this. So one suggestion is good. This I did, in fact. So P of alpha plus P of minus alpha. I mean, this is not a problem, right? This is the numerator is not a problem because, of course, it is like you can take the even and odd part. So it's just like 2, and I will write alpha only, so 2. So it's like P of x. So you will write x to the power, or alpha. I can use alpha if it is there. No, or x only, right? So P of x, more comfortable. Px plus P of minus x, that is actually 2 times, and x to the 6. Just take all the even ones, right? Then, oh, this is that there is some mistake? 4x5 and 3x squared and x16 plus 8.
And 16 comes.
1 minute. X6 plus. Let me just check that if there is some typo. I don't think so, but let me check that. 4x to the 5, x to the 6 plus 4, x to the 5, 8x to the 4. One term is missing. One term. That's why I thought that. See, one term is missing. 8x to the 4. Please add it. This is missing. 8x to the 4. I suspected because the moment I found that it can't be that suddenly fourth term is missing. Everybody is present. No, you know the joke of lion, that everybody is present and lion is in the fridge. Okay, so see, this is there. So 2x to the 6. So maybe that some people who are trying x squared plus 2 whole cube or something, they may get some lead now. So till now, x6 plus, I will write 8x to the 4 and plus 16x squared, and this is 8, 2 times, right? This is all 8. So this part is easily understandable because I'll get x squared for our problem. X squared is root 2 and x to the 4 is 2. And so this is, numerator is not a problem. Quickly it evaluates, right? For denominator, now you have to think of this one, that what it will go to. But chapter is Sophie Germain, right? So P of x and P of minus, when you multiply, think like this, right? P of x as ax plus x bx and ax minus x bx. So what I'm doing here is that ax part is the even part. So I'm writing ax as ax is x to the 6 plus 8x to the 4 and plus 16x squared and plus 8. And this bx is now this one, 12x cubed, 4x to the 5 and plus 12x cubed. This one plus 12x cubed plus 16x. That's all, right? Only 3 terms, right? Total, you have got 1, 2, 3, 4, 5, 6, 7. So 4 and 3. And so I can take x out here and I can write 4x to the 4 plus 12x squared plus 16. So everything in terms of x squared, right? So when you do this one, you are getting a squared minus x squared b squared. I'm writing a for ax. And so if I write x squared is t, again, new variable t, then what you are getting actually is, it is little simplified, t cubed plus 8t squared plus 16t plus 8 whole squared minus this is t and b squared. So you're getting 4t squared plus 12t plus 16 whole squared. Is that clear till here? It's just getting your house in order, choosing notations, doing something. If you simplify that, which will come, of course, by raising to power expanding, that's not bad, because you will get that like a squared plus b squared plus c squared plus d squared plus 2 sigma ab. So that is easy to, it is not cube, at least it is squared. So what do you get? Can someone tell what he is getting after simplifying this? Looks like a monstrous thing, but there is a light at the end of the tunnel. So you will get something really beautiful. You'll be rewarded. Somebody will say something that, yes, I got this. And then I can tell you that what you should expect. See, t cube term. No, this square term will not cancel.
Sir,
8 square will not cancel. Yes.
we can take the first and the last term and the middle two terms. That way we can get a t plus 2 term common. Yeah.
Yeah, we can do that. But ultimately, you have to. There is after that. It is just
The
simplification, right?
the exponent 5 and the coefficients will get cancelled.
Yeah. So what you get ultimately, some nice things. Somebody, I want someone to just answer. It is just expand and quickly tell me. Lot of, no, lot of cancellation will take place. Bloodbath, and then peace will be restored. Things will get worse before they get better. Just two things you will get. Now you can tell which two things, right? Because I know at least two things we know. At least two things we know. I have told you you will get exactly two things. So those are the things. So is it that you are getting t to the 6 and plus 64? If you do correct calculation, we should get this, unless we have made some mistake.
Yes, sir. X to the 6 plus 64.
Correct. Good. So x to the 12 plus 64. So now it is done. See, it's actually it's a reverse problem, right? This also is a famous problem. In some kind of things come that factorize x to the 12 plus 64. You can get 4 factors. So one using Sophie Germain and one using sum of cubes. And then you will know what happens, then you can uncover these two numbers. And what they did, what the proposer did, that they just, so suppose you get A1, B1, C1, D1 here, or A1, B1, I have taken the name. So let's write PQRS. What this did, that somebody just multiplied P and R and Q and S, something like that. And so he created, and that he named P. So is that problem clear? So if you do, after this, you will get the answer easily. I can just write the answer for your benefit. Somebody who will check the video later and they'll know. You should get 2/3, so 2 divided by 3 and plus 1 over root 2. That should be your answer. So it's a little computational, but it has got its charms and its strengths. I will say maybe that it is like IOQM 5 marks question. I will say like that. Certainly not for RMO, right? Because it's computational. It's like AMC or those kind of questions. But again, I don't believe in much this kind of thing. I just believe in good questions, right? And then, of course, it is up to the examiner or paper setter or the contest writer to make use or place it somewhere, right? That is a separate job. We just learn, focus on the subject. No, we love, okay, it is like this. We learn something out of it. Okay, so now this we did. So now I will come back to this problem a little later. So let me. Okay, this should be a little easy for you. This you try, this one. The moment you see what you see, it is things looks like big, but what are these two, product of these two? Now our eyes are
Power
trained.
4 plus 4.
Correct, because it is actually a minus b squared plus b squared, those things, right? So so it is actually a to the 4 and plus 4. And b to the 4 plus 4. And there is whole story here. So tell me that you are getting this or not. This is not as bad as the last one. Okay, someone got it? Okay, let me complete it. Although some of you might have reached at some point. So there is something good about it. So a to the 4, b to the 4 plus 4a squared b squared plus 4, and plus you are getting 4a squared b squared plus 16ab and plus 16, right? So I mean 6, and here if I expand this one, this is a to the 4, b to the 4 plus 4 times a to the 4 plus b to the 4 and plus 16, and that equals like this. So this cancels.
It's
16
done.
done. Okay, 16 already cancelled. This cancels. So when you club together all the terms, see this 4 is there, right? This 4 is throughout cancelled. So a to the 4 plus b to the 4, and that equals 4a squared b. Sorry, 4 is gone. So that equals 2a squared b squared and plus 8ab. 16ab was there, right? So 4 is taken throughout. So 8ab and plus.
So only 4ab.
Only 4ab. Why? Because this is 16.
We are
16ab is here.
we are taking 4 common. So
So
4 into
okay,
4
4
is equal
correct.
to
4 is okay, correct. So only 4. So that is 2, correct. And plus 4ab and plus 1, right? I hope this you will get.
So in the right hand side we will do 4a square b square minus 2a square b square.
Yes. So right side we can do a4 plus b4, and I can write here. This is here. It is correct. All right. Everybody got clear? Correct. 4a squared b square is coming, or yes, 4. This is 2a squared b squared is coming. So that is all right till here. So I will write this minus. I can write this and say I can add 2a squared b squared here, right? So if I add that, I will get 4a squared b squared plus 4ab plus 1. So I mean that becomes, both sides become perfect square, and so difference of squares applies. So I get 2ab plus 1 whole squared, right? So either a squared plus b squared is 2ab plus 1, or a squared plus b squared is negative of 2a plus 1, which is not possible because in this side when it goes, it becomes a plus b whole squared plus 1 is 0. So only this is possible, giving you a minus b whole squared is 1, and so modulus of a minus b equals 1. So little factorization, and then you're adding a factor, you are getting it. Okay. Let us do this one. 4ab minus 1 whole squared plus 4a plus b whole squared. They all now you see the thing that everything has been arranged just as to give Sophie Germain in the end. So that is how this different problems have been created. I mean, when you look at it first, it looks like that it is too monstrous. A squared, b squared, something. By the way, quickly, this one someone can tell, and he can be quick. 1 minus xy whole squared plus x plus y whole squared. What is that? Tell it as if you know, quickly. 1 minus xy whole squared plus x plus y whole squared.
X square plus y square plus xy square plus 1.
So what is that?
Sir, x square plus 1 into y square plus 1.
Yes, this is this one. This is a good identity. See, in algebra, first of all, you should know many entities, and whichever something good occurs, then then you do it. Like in complex number also it happens. It can in complex number it happens like this, that you write 1 minus, no, then you will find in modulus that 1 minus g1 g2 mod bar square will come. Those who are in 11 and 12, they can appreciate this. You will find this is 1 plus modulus g1 square and times 1 plus modulus g2 squared. So you can understand that, okay, this might be an extension, because of course you cannot put G2 now, G2 bar is there. No, and this is all right. This is unnecessary. I'm writing this is anything will work because anything is equal. So this kind of thing, you will find that, okay, and of course, when complex number is there, you know that modulus of alpha square operates like alpha alpha bar. So just check it later. You will find interesting thing, and you can derive many good things from here. Many exams I've given, notably IIT and other things. Okay. So now this is this. So what they did here, that is just 2a 2, right? It is just writing 2a and 2b. So you get the makeup 2a 2b. So it means it is nothing but 1 plus 4x squared and 1 plus 4y squared. But Sophie Germain has power 4, right? That is all right. We want not this. We are working with e a square b square. We are working with e of a squared b square. You want not ab. And so this is 4a to the 4 plus 1 and 4b to the 4 plus 1. And then remember, I wrote something there. So this is 2a squared minus 2a squared minus 2a plus 1 and 2a squared plus a plus 1. Just check my work. And so you will get here, and then similarly for this side. So you're writing a minus 1 squared and plus a squared and a plus 1 squared plus a squared. This is 2. And similarly for b, right? So now when you say this one, just look at first this one. So 20 squared, something 20 squared. It means that this number, this is like, if it is a square, then you're getting a square plus 1 less and 1 more. So 20 squared and plus 20 square, 1 less than this divides it. So this divides this. And when you go this factor, 23, this one b here, 2023, then you use the other one. That now b plus 1 squared plus b squared, because when b is 2023, then you are saying that divides this. No, I mean if it is in, so you said this one, that 4 into the 4 plus 1 is divisible by n squared. Take n squared plus 1 less n minus 1 whole squared, and also by n squared plus n plus 1 whole squared. So for one part you are using this one, and other part you are, so 1 2020 and 1 less, and 1 2023 and 1 more. So taken together, you are saying that is divisible. Of course, you can find that they don't have a common factor. So this is just presented in garb of this one. No? It looks like that, okay, let EAB, complicating everything and writing let EAB is this, and then big numbers square. So it has a feel of those things. Okay. So some problem I will leave for your practice also. So I have created like that 13 questions or something, a prime number of questions. Now one, let me do this one. This one telescopic series, of course, everybody should know telescopic series, right? Some idea must be there. So this one, we will do this one. Some answer will come, integer answer will come.
Sir, what is A? And I think A2 must be A1.
Yeah, this is A1. Yes, this is A1.
Sir, what is A?
What is A? A is this. An is this. Oh, okay. A is not. This is n squared. This shouldn't be n squared. Yeah, this should be n squared. This should be 2n squared. Let me just check. This is 2n squared. Must be this is a typo, A2, and I think this also, yes, 2n squared, correct. Now it is perfect.
Parth, you want to say something?
Yes, you can say. At limit, we try to make it as interactive as it gets. So one good hint could be that you think of this is right k root a sub k, right? K a k. Okay, this one. So we will deal with n squared an, right? That is good to deal with because anyway we have to multiply again, no? N square an, and then we have to take root. So if you write n square an, then things little bit improves. So they improve like this. N square an is so n squared, okay, n minus 2n to the 4, and over this thing, of course, whenever is there, I will of course rationalize it's too heavy. So I'll write 1 plus 4n squared plus 1 and square root of 1 plus 4n squared minus 1. And of course, I'll multiply here 1 plus 1 square root of 1 plus.
Sir, I think it should be 1 plus 4n to the 4.
4 into the 4. Okay, let me check. 4 into the 4. Let me check the original. Yeah, good. Into the 4, correct. Yes, into the 4. Just make the correction class. This is into the 4. You could have got later that because this will not come then. Yes. So this is 1 plus 4 into the 4, then into the 4 minus 1. And
Otherwise,
into
the
the 4.
thing won't exist.
Yeah, that is
square
correct. Yes. So n square minus then see this something cancels out, right? Into the 4 you will get 2 into the 4, and over you will get 4 into the 4 right now after doing a plus b minus b. And the square root of 1 plus 4 into the 4 minus 1. This has come up. So we are good till now. So n square minus, or I can write plus n square plus 1 minus root of 1 plus 4 into the 4, and over 2 have come up, over 2. So 2 is good news. So this will be, I will be writing this as 2n squared plus 1 minus 1 plus 4 into the 4 over 2. And you see, this likely this term is 2ab, and so multiply by 2 again here. So if you multiply by 2 again here, you will get 2n squared an, 2n squared an. That will become 4n squared plus 2 minus 2 times square root of 1 plus 4 to the n4, and over 2. This 2 is gone. This 2 is gone. Yes, no, this 2 is still here because I multiplied here, right? So I can write this 4 or this 2 I write. And now this thing, now Sophie Germain comes in the picture because 1 plus 4 into the 4. So that is your 2n squared minus 2n plus 1 and 2n squared plus 2n plus 1. And they do add up to this one, no? I mean that this was 2n squared plus 1 and plus 2n squared. No, 2n squared, it was 2n squared minus 2n plus 1 and plus 2n squared plus 2n plus 1, right? It was like this. So you understand now that if I take here, so I'll get n squared an is 1 by 4, I'll write here 1 by 4 times, and this is your square root of 2n squared minus 2n plus 1 and minus 2n squared plus 2n plus 1, this whole squared. No, this one we are getting n squared an. And so if you think of n times an, so n times an I get as 1 over 2 and the square root of 2n squared plus, so 2n squared plus 2n, this would be right. So okay, minus I can write, but here I have to change positive negative 2n squared plus 2n plus 1 and minus, so n and root an, this one, and negative root of 2n squared minus 2n plus 1. And one more thing here you can notice, that for telescopic thing, that this, if you change n to n to n minus 1, then this will turn into this. Right, that you can just not multiply, just you can see by multiplying this one, not multiplying, just taking common. 2n is common, n plus 1. And here this is 2n and n minus 1. So you see this one. So that is fit for now telescopic series, because things will cancel in pairs, and then you're left with just first and last, and then you will get the answer. If you do it correctly, you should get 14 as the answer. Let me write the answer for you. You should get 14 as the answer. So this is what we will get as. So this is one application of telescopic series, telescopic summation maybe. Similarly, I have included telescopic product also. You can check that also. All right, till here. Any doubt in this question? Anything? Okay. Okay, the next question that I am telling you is like, there is a little bit of personal history here. So this problem actually was communicated to me, or it was just, I had gone to like USA math camp, like that math camp was awesome. In fact, awesome math camp, which you know that T2 directs that. So I was sitting just across T2, and I was teaching geometry class over there, right? It was summer of 2015, right? So I was teaching a geometry course there, and with me there was a person who you might be knowing, because he's been the co-author for many books, Alok Muskarov. So I was sitting, Alok was there, and T2 was there. And then maybe he was proposing a problem that he runs a magnetic mathematical reflections MR. So he just asked me, Alok, what do you think of this problem? So he gave me this problem. What do you think of this problem? So I really like this problem. And it was another matter that I could just think of solution. So I could just notice of something, like you will notice that. So the moment it was given, I thought I knew that, okay, it must be this, because the powers, no. So someone can point out, right?
Important.
Uh,
One by one. Yes.
2401 is 7 raised to 4, right?
Yeah, that's the good thing.
And that 1024000 is going to be 4 times some.
Yeah.
4.
So 2 to the 10,
We
and then
take a is equal to 4 times 10 to the power 504, and b is equal to 7.
Means that, see, those are all details. Like the thing to notice first is that first you also notice 7 to the 4, right? No. So later I tried to make up a problem, but then if some of you are successful, let me know. So can you think of this one, that I just thought that, okay, so 7 to the 4 was no, so 2401 is known number, right? Power we remember almost, no, 7 to the 4, many of us at least. But then beauty was that 2401 and this is 1024 means they are just, by a coincidence, they are just arrangement of each other, right? So try to think of a number and let me know later on my email or something, that to make up a problem that this should be a 4th power, and here whatever comes, I don't matter, but I don't care. But then of course there must be permutation of that, arrangement of that, and Sophie Germain should work. It's not that there is a permutation, but Sophie Germain does not work because you can't take 4 out of it or something. So do try to make up a problem on that. Okay, I would be happy about it. Okay, so now this is as you rightly told, 7 to the 4 is there, and this is here, and this is all we can count now. So this is 1024 and times 10 to the, how many will come? Because already we have got 3, no, 1 0 gone here. So 213 zeros, and this 1 2 3 digits, non-zero digits. So 10 to the 2016 and plus 2401. That's what we are doing, right? So I'll write this as first. So 7 to the 4 plus 4 I will take out. So 7 to the 4 plus 4 and times, if you take out 4, then you are left here with 2 to the 10 was there, right? So 2 to the 8 is coming. So this is 2 to the 8. And then 10 to the 2016. So I can write 10. I want only this one. So 10 to the 506. I want n to the 4. And this also then I will write the same way. So this is 2, 2, and 4. So this is 7 to the 4 plus 4 times, and this is 4. They're all details that you can complete later also. 4. And so now
10
we are
to
done.
504.
Yeah, it's. Can you tell? You're telling something?
10 to the 504.
504, correct, 504. So you can create these details. So this is there 504, and then you can, of course, it has come to the a to the 4 plus 4b4, and we noted earlier only that even if b greater than 1, it works. Even if n b is much greater, even if b greater than 1, then it breaks into two factors. The smaller one itself larger than 1 by virtue of just b, what not even to talk of a minus b squared, and so it is composite. So that way it's all right. That okay, you get the feeling. I like this problem because this is 2401. People are reminded of then that 2401, and suddenly it comes out of blue. Yeah.
10 to the power 2012. Since
2012, what is it? Okay,
so
some
you are to the power
one by one. You are telling some other question.
No. 10 to the power 2012 after 1024. Shouldn't it be that? In the calculation. Overall,
no, it is I think 2016 only, because see, total of that many zeros, 20140. So 10 is accounted for here. So you have got here 2013 zeros and then 3 non-zero digit also. So total 2016 numbers.
Yes, sir. Now understood.
Correct. So anyway, you could have checked that later also, right? Because of course I told you that like details are left to you. We just know that okay, this is at the heart of it, right? But all right, good one. Okay, so this is this, and let me go pick some. Here you will find it will lead to Pell's equation. This one, you see here. So I will not complete it because Pell's equation many of you might not know, but then see how this problem leads it to it. If you write this as, say, write AK as k to the 4 plus a to the 4, 1 to the 4 notation, and we are dealing with a1, a2, an. They are saying rational number. Okay. So when I break it up, this is k squared plus k plus 1 over 2 and times k squared minus k plus 1 over 2. And so I can still write it as, let me write it as bk and bk minus 1. I will write this as k, bk and bk plus 1. So my bk, b sub k is k squared minus k plus 1 over 2. So this is bk and bk plus 1. Just check that they turn into this if you replace k with k plus 1. So you understand now that this is pi ak, k equal to 1 to n. And so this looks like a1, a2, no, b1. So this is like, good notation always helps in Polya style, b1, b2, b2, b3, keep on going. Last is bn, bn plus 1. And so we know that b1 and bn plus 1, the odd man out, they could not find a pair. Everything else is paired, like b2 is squared, b3 is squared. These two are unlucky people, so they have to be content with themselves. So b1, bn plus 1. And so now b1 is anyway rational, right? b1 is rational. So b1 also you leave. So b of n plus 1. And that is nothing but n squared plus n plus 1 over 2. This one. And then you want this to be a rational number, right? Perfect square. A square person, so you want perfect square. You want this to be m squared something. So this leads to 2n squared plus 2n plus 1 is 2m squared. And when you multiply by 2, right, then 4n squared. So multiply, let me change the color, 4n squared plus 4n and plus.
Sir, I think
this is 1 over 2, correct? Yes. What is that?
Sir, I think we would need B1.
B1 you would need? Okay, correct. B1 you would need because perfect. So B1 is 1 over 2 or what? B1 is B1. What is B1? B1 is here. B1 is
half.
B1. Okay, 1 over 2. Correct. Yes, we would need that. You are right. So let me write this here. So this is 1 over 2. Okay, perfect square. Okay, and n squared plus n plus 1 over 2, and that equals m squared, right? This one.
Yeah.
So I will get 2n squared. I can take this 2 now and 1, and that is now 4n is 4m squared. This one. Yes, that is now 4m squared. Correct. So now multiply by 2. So if you multiply by 2 now, then you are getting here 4n squared plus 4n plus 2, why 2 is coming, but 2, okay, 2 is all right, 2 will come, is 8m squared. So I can write this as 2n plus 1 whole squared. Then 1 I wanted, that is here, 1 is there, I got my 1. And this is 2 times 2m whole squared. And so you see now x squared minus 2y squared equal to -1. No. So that's a Pell's equation, right? So it will lead to Pell's equation. This one, this simple problem. It's starting very simple, but then leading to Pell's equation. So some of you can read about it later. Although if you reach in MOTC camp, then they will teach you in some number theory classes, but you can read on your own also.
Sir, we also have a Pell's equation lecture.
Okay,
tomorrow.
okay, good. Okay, good. So it's like my placement is correct. That Pell's equation. Okay. Okay, so let me go quickly to one more question. Other things, see, this is all you understand. This is for your practice also, because I always want my students to do well. So some of them I have left as a gift from myself to you, that you will work it out later. Okay, so they will be equally good. Like this telescopic product, you will find when you do it that things will cancel. And then let me do one our problem, this one. Let me show you first this one. That this quickly one remark. See, especially those who are in class 11 and 12. Anything then in one matrix, no one. If there are A and B two matrices, then they don't commute, and so it becomes dangerous. Like you can't have, see, xy is x plus y, right? In matrix notation, if I write I minus A, even if those who do not know, please listen carefully. It is not earth shattering. Suppose I write something like this: I minus A minus B. If I multiply, I will get I minus B term by term minus AI and plus AB, right? Is I. This one. And if I do the order different, then it is different, right? Here it will be same. Why? Because you understand xy equal to I is there, so you will know that it means that they are both invertible, some sort of thing, and so I can put y before x also. In fact, there is a famous Putnam problem that AB is A plus B. Then prove that A and B commute. A and B are matrices such that AB is A plus B. Prove that A and B commute. So some people just start that, okay, just write BA equal to A plus B. Of course, that is not true, no, because they are saying that A times B. So it is like A pre-multiplied with B. That's the matrix language. So it was a good problem that it came, that A and B two matrices such that AB is A plus B, prove that they commute. So one can write actually it like this. One can write I minus A, I minus B equals I, and then he can turn them around, because it does not matter. I will take care of that. That you can prove later, that if PQ equal to I, then of course it implies that QP also equals I, because PQ equals to I means that P and Q both are inverse of each other. So it does not matter where I put it. No, this one. And then, so once you put it like this one, no, I minus B, I minus A equal to A. Now we have put B before A. So it will follow commutes, and we follow. Why? Because this is I minus, this is I. So this is now it will be I minus A and minus B plus BA. So you have successfully turned the side, right? A plus B you can't turn, because A plus B sum, of course, is sum. A plus B is B plus A matrix. No. So addition is commutative, multiplication is not, right, in general. And so this is, you are getting BA is A plus B, but well, BA is A plus B and BA is AB, so you get A and B commute. This is the thing to take care in 3 variables, right? 2 variables. In 1 variable, you're just excellent. Each question that you do in matrix can be done by corresponding algebra. Like if you x squared minus 1 is x minus 1 x plus 1, so good. A squared minus I is of course A minus I A plus I, because A and I commute. Any matrix commute with I is a sleeping matrix, right? So it commutes. But A squared minus B squared you cannot write. A minus B A plus B, no, this you cannot write. That's the first thing we teach you in matrix, that this you cannot write, because we do not know that AB and BA equal or not. But this you can write. Such nice things are restored when you say that, okay, let A and B commute. Then you get binomial theorem also, A plus B whole to the n. Again becomes same thing as if A plus B whole to the n. But if you work with I plus A to the n, you don't have to worry about, because I and A commute. So anything that relates to A, you will do many algebra courses in future also, and in UG also. So these things will be effective. So it is just like that A to the 4 equal to I is, for me, I have to think of that, okay, x to the 4 is 1 given. Think of something like that, x to the 4, 1 something 1. and I am to make up my mind about 2x square, I have to think of what is 2x square plus 2x plus 1 and 2x square minus 2x plus 1 to deal with this kind of thing. What are they do with this? Then this Sophie will come to your mind, and then you will understand that okay, so you will understand that okay, 2x squared plus 2x, so the identity is this 2x squared minus 2x plus 1. That actually is known as 4 to 4 plus 1. That's what our topic was. So it's just like somebody saying that okay, just replace x with a and 1 with I. Of course, a and 1, no, they are chalk and cheese. They will not add up. And so math are very clever people. They will just write I. No, just like so a plus. So the moment you write 4a to the 4 plus I, then it becomes your this identity 2a squared plus 2a plus I and times this one. So deep down they are both Sophie Germain. They are not actually nothing. This matrix is just the language setup. No, it is dressed out the matrix problem. Deep down it is Sophie Germain. And so here you get this is they are given this is I, a to the 4 is I. So it means this is 5 times I is something. Means you are saying that two matrices P and Q, PQ is lambda times I. So of course P and Q both have to be invertible. No, I can write P over lambda or something I can write. And I can say that okay, Q inverse of Q is P over lambda. If you're inverse of P, then this, right? So this kind of thing is there. So it is actually not a different question. Similarly, many other things that you learn in say 11 and 12 matrix, when single matrix is there A, then feel free to find often the corresponding identity that is hiding behind that problem, because that's the problem is not about matrix, it's about algebra. Okay, I hope this is clear. One last one I will take up is this one, is the Romanian Olympiad question, because regional RMO many people might have done also, I'm sure 29, and I will teach you one little thing here, that's all. So first of all, when you do Sophie Germain here, then you are rating till here, that 3 and 4. So we are writing 4 times 4 to the 5 to the 6 minus 1 over 4. This is, and then to the 4. So you are making your house in order. That's simply getting everything. And plus 3 to the 4 to the 5 minus 1 and whole to the 4. So I got my A, I got my B. I should not complain now then. 3 to the 4 to the 5 minus 1. And B is 4 to the, this I have to compute because I need to now not only this, but something greater than the way the problem of India was there, no RMO and ROMO. So we are doing ROMO now. So now this is 4 to the power. I need to compute 5, 6 minus 1 by 4. That's not bad because 5 to the 6 is 5 cube squared. That is 125 squared. And you know, for a square, what you do that if it is x5 and x5, you might know some of the trick. That is 25 and just multiply x with x plus 1, right? So it is 12 times 13 will come, right? So 15625. That will be this one. Suppose you want 35. These are some basic maths sometime. So 25 and this is 1225 like that. X plus 1. Of course, you can derive it how it comes. So this is now 15625 and divide by 4. So that should be 4, 3. This is should be 4. So 3, and then you will get this is 3, 4, 9. 3, 9 you are getting, and then 0, 6 because 1 you will have to minus here. 1 is subtracted. So 4 to 3, 9, 0, 6, which I will write. And you know, we have already discovered this one. So our mind is settled. We discovered already. So we'll not spam it by writing these big expression 3 to the power 4 to the 5 and 8 to the 11. Thus now here that your expression E is this, and you are saying that okay, a smaller one is this already. So if I can prove that b square greater than this number, then my job is done. No, greater than. So what is b square? This is first 2 to the power, or this is 4 to the power, this one 4 to the power 7, 9. No, this is 7, 8, 1, 2, right? This is just check my work first. It is all right. So it is 4 to the power 7, 8, 1, 2, this one. And this you want to prove that this is greater than 10 to the 2009. This one you want. Okay, so can you do it now? Can you take some time to do it, just 1 or 2 minutes? First check the calculation and all the work.
4 to the 5 is greater than 10 to the 3.
4 to the 3976 you want, and so you have to
4
yes,
4 to the 5 is greater than 10 to the 3, and so this is pretty easy.
yeah, you can say 4 to the, this is 4 to the 7812, right? Just check this work first. This is 4 to the 3906.
Sir, I think we can tell that to the power 7812, so it would be 16 to the power 3906, and 16 is greater than 10, so it would obviously be greater than 10 to the power 2009.
Okay, so just check this one, that 4, no, we have taken 1 4 out, right? So 1 4 out you have taken, so this is 5 to the, it is not, it will not be so obvious, but let's check anyway. So 4 to the 5 6 minus 1, it is here. So this is this, and A is this one. Oh, this is divided by 4. So divide by 4 if you do, then you get 3906. This one. So 3906, and then you have to prove that product of 2 is greater than 10 to the 2009. Okay, so I think then you can do, so basically I follow these things. So 2 more things I can tell you. See, when you compare power of 2 and power of 5, then you should come, this is a good estimate, that 2 to the 7 greater than 5 to the 3, because they are much closer. So whenever you have to, so I can do this here. No, this also will be okay. If it is not very obvious, then this kind of thing will work, 2 to the 7 and 5 to the 3, because they are really close. So normally when you calculate powers of 2 or we compute, then we do this kind of thing. Simple estimation. Okay, anything you want to ask? Maybe the lecture time is like, okay, so because you might have another lecture or something. So I think it is for now time for question answer session, right? I think some moderator will tell. I think I got the same information.
Yes, sir.
So you can ask anything you want. Not, it may be something else also, not exactly this, like some suggestions, some advice, anything you can. It's well open house. Yes.
So in this question, we have delineated 4 is to 3906. So can we also prove that it's greater than 10 is to 39 by saying that b square will be 16 raised to 3?
Yeah, I'm not able to hear you. So can you speak? Can you put your mic something or something? Yeah, please tell now.
So I'm saying that can we also do it like b square will be 16 raised to 3906. So both the base and the power are greater in b square.
Maybe like you are saying that you can prove by other method. You are saying?
No, sir, this method.
Yeah. So yeah, but after that, last step estimation you can do. You can have your own estimation also, as long as it is correct. That's not a problem. And it's not the best result. They just put some number, right? It is far exceeding that this number. They just, because year was this one, so they put this one, right? Maybe you do, it will come 10 to the 204 2406, so that the problem remains valid even till even 400 later. Also problems can be used if the books survive. Okay, so that kind of thing.
Okay.
Anything else? Okay, a piece of advice from my side, maybe, because some of you, this is the question that I've been getting over the years as a teacher. And so let me tell you this one, that some people do ask that okay, they are preparing, some people are preparing for, say, of course, all of you will follow different paths. Okay, so somebody will go to a math career, somebody will choose engineering career or something. But anyway, math, of course, you have to study, right? So those who are in class 9 and 10, so I really even 8 also. So you can read much mathematics till class 10. Why? Because you have got a lot of time. So your school does not give you much homework, right? School syllabus is pretty easy. So devote this time to learn more and more of maths. Even if you want to go for engineering career, this will help you, because ultimately it's like I say it's seamless mathematics, right? It's not that it is, you have to make a compartment that this is IT mathematics or this is Olympiad. See, if you think this way also, then if you do analysis also, no, you will find that algebra is common to everything, like counting problems, binomial theorem, sequence series, basic quadratic, on which you can do many things. Like quadratic is like treasure house of problem for even Olympiad, right? So those things, quadratic equations, sequence series, binomial theorem, polynomials, transformation of roots, these things are integral. It's just that in Olympiad they come a notch higher. But even if you try for ISI, CMI, or you're writing IIT, then also these things remain useful, right? Even geometry, I would say that leave conic sections, but I mean geometry, I say that the geometry of line and plane, you can better understand if you have got feeling of geometry. So for example, you know how to construct things, then you will know that, okay, this is, even if you are doing some coordinate geometry problem, because that has been my experience both as a teacher and a student, from other side of the table also. When I was a class 10 student or 11, then I found that really the kind of geometric intuition I developed, that really helped me in coordinate geometry. See, in my time, there was a question in ITJ that was wrong. Of course, next day newspapers carried it that it was wrong. No, they gave a catchy headline also. It was that IIT's open Pandora's box. Now, those who, Times of India. Now, those who know, they know that, okay, Pandora's box means that there was some story that, okay, Pandora was invited somewhere, and she also wanted to gift something, or she gifted and said that don't open the box, don't open this, but some people are curious, they opened. It is said that after that only misery, everything started coming on earth. So something like that. Okay, so that's the whole point, is that this kind of thing. Now it is applied figuratively also, Pandora's box. Figuratively means that original meaning was something different. Now as a part of a speech, you apply something like this. Suppose today somebody wants to go for more estates, right? Already we have got a lot of estates, right? So people will say that don't make more estates, it will open Pandora's box. Means it will create more problems, like means you are inviting. So the question was wrong, but then I got it wrong. I got it correct. I got it like I got in the exam that it is wrong question, and I wrote also that this question seems to be, of course, one has to be polite very much. So I wrote that there seems to be a mistake in the question, because as the circles don't touch, okay, so there is no tangent at the common point of contact, and of course they will have different tangents. That was sure. Different tangent, of course, will be there. Indeed, one plus sign was turned to minus, or something happened other way around. So these things do happen. So I got the feeling, because geometrically I worked out, I found that no, they will not touch. Okay. Of course, common tangent was the second part. That of course will happen. In fact, lot many, because your work was increased. Because if they're touching, you have got just few of them to find. If this is what, then you have to do more work, right? So I would recommend all of you that you read all of them. Basically, number theory may be that not very useful, but algebra and geometry will be really useful, at least till circle. So this is anyway your time to read more and do more. So that is one advice, a piece of advice from my side. So that all of you are able, because you have reached till this limit camp. That's really, questions are really good. Very good questions are there in limit. I am myself, like I solve the questions of limit also, and then other contests also I keep looking at them. So really it has come up well. I think they're really doing a good work, these people. So that's all from my side. Unless you have any questions, I can continue for some time.
If there are no further questions, then we can stop.
Yes. So how will we get to know? We have to wait and see. That's the online thing, right? In class, we know by the.
Are there any algebraic tricks that do we need to know to solve all math Olympiad questions?
Please tell again. Are there? What's your name?
My name is Inesh.
Vignesh. What is?
Inesh. So.
Okay, so please tell what you're saying, that are there
some extra algebraic tricks or something like that that will boil down our problem solving to just 2 minutes or so in such a heavy
in Olympiad? No,
something like
Olympiad
that.
2 minutes is not Maggie. It's not Maggie Olympiad. 2 minutes is not a thing in Olympiad. But see, these are the questions which are, see, this question came in 2009 in RMO or RMO. Okay. So that time I can say that, okay, some questions are easy also. So that was easy in the sense. Okay. But then still, it was that if you got the idea correct, you will of course break it. But say this way, that don't think of time, just think of that how much more you can learn. For example, I would say Newton sums are useful. Newton sums, because dealing with powers of this one, alpha to the 5 plus beta to the 5, reconciliation useful in algebra. Then Lagrange's interpolation useful. Those things, or Gaussian coefficients. So those things you try to see, they will keep coming different mathematical literature. You can, so whatever. So I don't say them trick, but I say this some that useful device. Like, so there are some tools. This is one tool. So you must know before using the tool that whether this is really needed or not. No, right? Because right tool is important. No, whatever a sword can achieve, a bat cannot achieve, right? And the vice versa also. If you want to kill a mosquito, then of course you won't take a sword, right? You will take a bat or something, or flat paper. So I mean, you have to whatever small results you find, that all result you keep writing, and the best thing is that do just 10 problems around that. For example, if I want Sophie Germain, if somebody does these 10 problems, 13 problems, and something more from his side, he's ready. He knows the concept now. That's only you can do. After that, it is up to you to understand and apply it. That will come because it is already inside you. The moment your mind sees something, it will send you some kind of intuition that, okay, see, it smacks of this one. It looks like this one, and then you will be set. So just try to add more and more tools to yourself. Okay, probably that was daily you are doing a trick only. That same thing that. Okay. I mean, now we can end the session, right?
Yes, sir.
Okay, thanks everyone. And thanks the organizer for inviting me. It was really a good thing to interact, given the COVID scenario. At least teachers and students both are happy that they are able to interact somehow. Hope normalcy will be restored soon. Till then, goodbye, all of you.
Thank you, sir.
Okay, welcome.
Thank you, sir.
Okay.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Okay. Welcome.
Thanks, sir.
Okay, so should I drop out now? Ankan there or Sanchan is there? Who is there now?
Yes, sir. Thanks for the wonderful lecture. We can end this session right now.
Yes. Okay, thanks. So okay, so I should just end the meeting.
Yeah, sir. Yeah.